This is Lesson Master 4.3, where we're going to practice with the 4 theorems as well as the trig identities. We're going to be doing a little bit of both on this Lesson Master. All right, so it says that suppose cosine is negative 7/15. As soon as I see that, I have to think to myself, where does cosine go if it's negative? And that's actually what the first question even asks me. In what quadrants would this, if you were to rotate to theta from 1, 0 to negative 7/15, where could cosine possibly be? Well, we know that cosine, which is the x coordinate, so cosine is x coordinate. We know that that is negative on the left side of my coordinate plane and the left side of my unit circle, which would be in quadrants 2 and 3. Then it asks me to find all possible values of sine of theta. Well, I've got to think to myself, when I'm in quadrants 2 and 3, I need to think about the sine here. Sine is the y coordinate. And my y coordinate up here is positive, and down here is negative. So my final answer for sine is going to be plus or minus. Got to remember that. All right, so now I'm going to use that Pythagorean identity theorem, where I'm going to use cosine of theta squared plus sine of theta squared equals 1. Cosine is negative 7/15 squared plus sine of theta squared equals 1. So I get 49 225ths plus sine of theta squared equals, I'm going to say 225 225ths. Sorry, you can't see that 5 real well there. Okay, subtract the 49 225ths from both sides, and I get that sine of theta squared equals, it's going to be 176 over 225. When I take the square root, sine of theta is plus or minus. Do I want plus or minus? I do. And I get the square root of 176 over the square root of 176, if you put it in your calculator, is not an exact value, so I'm going to leave that for right now. The square root of 225 is an exact value, it's 15. So one possible answer is plus or minus the square root of 176 over 15. A better answer, the best answer, if I want to keep it exact, would be to reduce this 176. And you should have learned, just like how you simplify a fraction by dividing by things that the numerator and denominator have in common, you simplify a radical by looking for perfect squares. So if I did that, the square root of 176 is the square root of 16 times 11. Because I know that I just started trying perfect squares to see what went into 176, and 16 was the biggest one. So that becomes 4 times the square root of 11. So I could also write plus or minus 4 square root of 11 over 15. Either one of those could be my answer. All right, let's go to number 2. Every time I draw one of these circles, don't skip this step. I'll just tell you, don't skip that step. Cosine is positive. Where is cosine, which is the x coordinate? Where are my x coordinates positive? Over here. So sine in these two quadrants. Up here it's positive, down here it's negative. So plus or minus. Tangent up here is positive, down here is negative, so plus or minus. I don't want to forget that. Now I'm going to go ahead and use my Pythagorean identity theorem. So I've got lots of different work here, so I'm going to switch colors here just to maybe help me differentiate my work. So again, I'm using cosine squared plus sine squared equals 1. Cosine is square root of 17 over 7 squared plus sine squared equals 1. When I square a square root, I get 17. Square 7, I get 49 plus sine squared of theta equals 49 over 49. I'm going to subtract that 17/49 from both sides, and I get sine squared of theta equals 32 over 49. Take the square root, and I get that the sine of theta equals 32 is not a perfect square, so I'll leave it like that, over 7. So one answer that I can put here is the square root of 32 over 7. 32 does have a perfect square in it, though. 16, so I could rewrite the square root of 32 as 16 times 2, which becomes 4 square root of 2 over 7, which is the best answer. Tangent is simply going to be sine over cosine. So I'm going to switch colors again. Keep doing my work here on the side. Tangent is sine, which is, I'm going to leave it as a square root of 32 for now. And then it's just going to be easier to deal with, I'm thinking, possibly, than that, over cosine, which is square root of 17 over 7. And that means I'm going to multiply by the reciprocal, square root of 32 over 7 times 7 over square root of 17. 7's cancel, and I get tangent of theta equals plus or minus, well, it's going to be plus or minus, I don't need to worry about that yet, square root of 32 over square root of 17. I can't leave it like that. I need to rationalize my denominator. So I multiply by square root of 17 over square root of 17. And now is where I'm thinking, I really don't like this 32 and 17. Maybe I should write 4 square root of 2 times square root of 17. I'm using the 4 square root of 2 instead of the square root of 32. And then I would end up with 4 square root of 34, because 17 times 2, all over 17. So it was easier when I got to this step to have the 4 square root of 2, because then it just becomes 4 square root of 34. So plus or minus 4 square root of 34 all over 17. That's my final answer for tangent. So notice in these problems, there's a lot of algebra that you have to know. You have to know to rationalize denominators by multiplying by square root of 17 over square root of 17. You need to know how to simplify radicals. So lots of things that we need to practice here. All right, so far on this lesson, Master, we've done a bunch of work with the Pythagorean identity theorem. Now we're going to switch gears when we get to this one. The sine of theta, okay, I'm going to draw my circle. Sine of theta is positive. Where is sine positive? Sine is positive up here, because sine is the y coordinate. Sine of opposite of theta. Opposite means above and below. So I'm up above, and now I'm below. When I move below, sine becomes negative, and the number stays the same. Okay? So what's happening is I'm moving to here for letter A. Now let's look at letter B. Again, sine is positive, so it's up here. Pi minus theta. When I look at that on my 4 theorems, that means there's supplements, and I move side to side. So I move this way, or I move this way. Well, then nothing changed. It just stayed up top in the positive, so it stays positive 0.78. You need to draw these circles and then draw arrows to where they're moving. If you don't, you're going to end up guessing and maybe at best get it right half the time, which is a 50%, which is not passing. So you want to make sure that for each problem, you shade where it starts and you draw an arrow where it ends. Okay, that's what we did here. In 3A, it started in these top two quadrants, moves above and below, so it went down here to the negative quadrants. In letter B, started up above, and it moves side to side, which means it didn't move as far as becoming positive or negative. All right, let's go to number 4. This tells me what the cosine is. It's negative, and it tells me which quadrant it's in. It's only in one quadrant then. This is saying from pi to 3 pi over 2, which is this quadrant right here. That's where I'm going to go. This right here is where we're adding 180, so we're moving halfway across the circle, which is diagonal. I'm moving to here. Well, my cosine is negative here. In this quadrant, my cosine is positive, so it's positive 0.267. All right. Now, for letter C, let's see. For this one, okay, so sorry, I didn't even have that there. We have that we are again starting in quadrant 3, and opposite means that we are moving above and below, so we are moving above. But notice this is sine, it's not cosine. So the sine up in this quadrant is positive. That's why I had that there. I had already put that there. So this sine is positive. But now we need the number part. We know the cosine, but we don't know the sine, so we're going to come back to using our Pythagorean identity theorem, which says cosine squared plus sine squared equals 1. Cosine is 0.267 squared plus sine squared equals 1. So when I square that 0.267, I get, and you could say, well, wasn't it negative? It was. But when I square it, it's going to become positive, and I get 0.071289 plus sine squared of theta equals 1. When I subtract this from both sides, I get that sine squared of theta equals 0.928711, and then take the square root, and I get that sine of theta, I don't need plus or minus, I only need plus, and I get 0.964. I go to 3 decimal places since this was 3 decimal places. All right, this next one is tangent. Sorry that got covered over. All right, again, where did I start? I started in this quadrant. This right here means side to side because they're supplementary, so I move to the side here. And I've got to think about the tangent in this quadrant. In this quadrant, because this is the positive negative quadrant, the tangent becomes negative. So this answer is going to be negative. So my tangent of theta is sine over cosine, which is 0.964 over the negative 0.267, or just do the 0.267. I already know that it's negative, and I get 3.610 when I divide this on my calculator. And I know that the sign is negative.